Alright, this video I'm going to be looking at solving exponential equations. So all the equations, all the examples I'm looking at will have exponents involved. They're in exponential form. Now before I jump into this, one important theorem and formula we're going to need to know is that if you have two exponential equations equal to each other, or exponentials on both sides, and if the bases are the same, what you can say is then the exponents must be the same. So that is a theorem there that if the bases are the same, then exponents are the same. So we may need to use that, may not. So also, since we're dealing with exponentials, we might run into logs, because remember, logs and exponents. A log is an exponent, so we might need that down the line here. So our first example, we have 6 raised to the 2x minus 6. And then 36 raised to an exponent of 3x minus 5. So keeping that theorem in mind, if we have the same base, we can do some, pretty neat stuff there. So since we're solving, we're trying to solve for y. And I noticed that, since we're solving, we're trying to solve for x, and x is on both sides. One thing I notice here is over here, on the left side, I have a base of 6. On the right, I have a base of 36. Now, if you're, thinking mathematically, you should be thinking those bases are very, very close, but not quite the same. So what I'm going to do is I would like to rewrite one or both of these so that they have the same base. So if this is a base of 6, what if I rewrite this 36 so it has a base of 6? So the left side I'm going to leave alone. It's going to be 6 raised to the 2x minus 6. The right side, I'm going to rewrite 36 so it is also with a base of 6. But I got to think, 6 to what power would give me 36? Well, 2. So 6 squared will give me 36. Notice how this is now base 6, that's base 6. 6 squared is 36. One thing I still need there is this 3x minus 5 and as an exponent does not go away. It is still there. So then I'm going to do some basic solving here. Before I get into that, though, I got exponents raised to an exponent raised to an exponent. When we have that, properties of exponent says I got to take this 2 and multiply it by both that 3x and that minus 5. When I do that, I get 6 raised to the 6x minus 10. My left side, I did nothing there, so I have 2x minus 6. And what we should notice there is I have the same base and exponents there. If the bases are the same, the exponents are also equal to each other. So what we really have there is 2x minus 6 is equal to 6x minus 10. So I just went from an algebra 2 problem all the way back to an algebra 1 problem. So I'm just going to solve that. 2x minus 6 equals 6x minus 10. So I'd like to get my x's together. I'm going to subtract 2x from both sides. That'll leave me with negative 6 equals 4x minus 10. Got to isolate the x, get x all alone, so I'm going to add 10 to both sides. So I have 4 equals 4x. Only thing left to do is divide by 4, x equals 1. So that is my first example on solving exponential equations. Let's look at another one. So the second one I have 7 raised to the x equals 9. So think about that theorem that we used earlier. I would like for my bases to be the same, but 7 and 9, those aren't even close. I can't think of any obvious way, to make 7 and 9 have the same base. Well, the reason being is we can't use that theorem. We're going to have to go other routes. So right now the variable that I'm trying to get by itself is up in the exponent here. So I got to think, how can I get rid of this base of 7 so that I can get this x all by itself? Well, this is where logs comes in. I'm trying to solve for the exponent there. So what I'm going to do is, notice how this is a base of 7 raised to an x. I need to get rid of that base of 7. So we have to think back to one of our old properties, and if I take the log of 7 to the left side, I'm also going to do that on the right side. It's hard to see because it's all jammed up, so I'm going to rewrite it. I have log base 7 of 7 raised to the x is equal to log base 7 of 9. Now the reason why this works, we had a base of 7 there, so I took a log base 7, did to both sides. The reason why this works is, remember, if we have a base of 7, those are inverse operations, so those are gone. So what's left on the left side of this equal sign? Just a plain old x. So I have x equals log base 7 of 9. Only thing left to do is I have to figure out just, hey, what is log base 7 of 9? Because I want to know, if I'm solving here, I want to know the decimal equivalent there. So think back to our other lesson on how we can figure log base 7 of 9. We could use the change of base formula. So this top number 9 is going to stay on top. So we have log of 9 on the numerator. The 7, notice how it's kind of oriented towards the bottom. Well, it's going to be in our denominator. So if I do log of 9 divided by log of 7, I could figure out what log base 7 of 9 is, which thus is x. So I could take a calculator and type in log of 9 divided by log of 7. And I'm going to round that to 1.129. So that would be my x value and the solution to that exponential equation. I'm going to show you one last one, and this one's going to use e instead. So again, we're trying to solve equations. We're trying to get x by itself. So whenever we're solving any type of equation, we're always doing order of operations backwards. Get rid of addition, subtraction, multiplication, division, then deal with exponents, which is where my x is, and then if there was parentheses, go from there. So working backwards, first thing I'm going to do is I'm going to add 9 to both sides because I'm trying to get all these terms on the left side away from that x, where we're going to move on the right side. So if I do that, I'm going to have 3 times e raised to the 2x is equal to 27. So continuing from there, trying to pull all my numbers away from that x. This is 3 times that e, so I'm going to divide by 3 on both sides. So that gives me e raised to the 2x equals 9. So I got rid of the addition, subtraction, the multiplication. Now I'm dealing with that exponent. I got my variable up in the exponent. To get there, I need to get rid of this base of e. So we're going to kind of use a similar idea of what we used up there. To get rid of the base of e, I'm going to take a log with the same base of e. So really I'm trying to figure out log base e. But again, we don't write that. We take the natural log, because that is log base e. These are the same thing. But we don't write this, we write natural log. So this is log base e, so I have a base of e, and natural log of 9 on the other side. The reason why this works is, again, this is a base of e, that's a base of e, those are inverse operations. So I'm left with a 2x on the left side and natural log 9 on the right side. I would like to figure out what that is, or you could go ahead and divide by 2. Either or, it doesn't matter. You know what, actually I'm going to divide by 2, because again, I would like to get that x by itself. So you would divide by 2, divide by 2. So now I know x equals natural log of 9 divided by 2. So at that point, I got x by itself. Time to use the calculator. So we have natural log of 9 divided by 2. And I get 1.0, call it 1.099. So that was a quick review on solving exponential equations.